Okay, let's go ahead and find the distance between these 2 points at -5, 8 and 3, 3. Two different ways. The first thing we're going to do is use the Pythagorean theorem, and then the other way is we're going to use the distance formula. So using the Pythagorean theorem, I'm going to draw a right triangle here. Again, the hypotenuse is the segment connecting those 2 points. And then I drop a vertical segment down, the horizontal segment across here to form a right triangle. So making the assumption that every one of these grid lines is equal to 1 unit, let's look at the length of this particular segment. Let me point to it real quickly here, this particular segment right here. So that's 1, 2, 3, 4, 5, 6, 7, 8 units. And the length of this segment is 1, 2, 3, 4, 5 units. Okay. So now we're looking for the hypotenuse. So using the Pythagorean theorem that says leg squared plus leg squared equals the hypotenuse squared, we would say 5 squared plus 8 squared equals c squared. Let me get my calculator out. And 5 squared plus 8 squared gives us 89. So 89 equals c squared. Remember, we need to solve for c by undoing the square, by taking the square root of both sides. If I wanted an exact answer, I would say c is the square root of 89, but let's go ahead and get an approximation. So the square root of 89 is approximately, rounded to the nearest tenth, 9 4/10 of a unit. Okay, that's one way to do it. But if I use the distance formula, which was d equals the square root of the difference in x's squared plus the difference in y's squared. Okay, so we have -5 minus 3 quantity squared plus 8 minus 3 quantity squared. Well, see, -5 minus 3 is -8. 8 minus 3 here is 5. So -8 times -8, -8 quantity squared is going to be 64. And 5 squared is 25. So that gives us a square root of 89, which is approximately 9 4/10 of a unit.